Okay, here we go. The last thing that we did was that Fahrenheit and Celsius thing, right? I didn't give you a worksheet for that, right? But I'm going to give it to you today. So the second part of that same worksheet is what we're going to do today. It shouldn't take too long. Um, Basically, it's solving for a variable, but you don't have any numbers. All right, so you're solving in terms of something else. For instance, let me give you something. What if I gave you an equation like this? Volume equals length times width times height. Okay, it's a volume equation. In fact, I can give you equations and they don't even have to mean anything. All right, but this does mean something. That's an actual equation in geometry to find the volume of solid. So or rectangular solid. So what if they ask you this though? What if they asked you to find or solve for the width? So solve for W. That's what we're trying to solve for. Alright, so here's your equation you're starting with, and you want to solve for W. So let's rewrite it again. LWH. So if I want to solve for W, what do I have to get rid of? The L and the H. What are the L and the H doing to that W? How do you get rid of that? Right, so you just divide by what? L, right? You could do it one at a time, but I would do it all at once, all right? Because they're both, right, multiply by, or divide by L and H, wouldn't you? So if you do that to one side, you come over here, do that to the other side. Look, the L's cancel, the H's cancel. There it is. And that's your answer. W equals V over LH. Make sense? That's it. There's no numbers, right? It's not like the answer is 3 or 7 or 2.4, this is our answer. That's what the width is in terms of V, L, and H. You hear what I just said? We're finding the width in terms of the other variables, in terms of V, L, and H. When I say that phrase, in terms of, that means that that letter is going to be part of your answer. So if I said solve for W in terms of V, L, and H, that means V, L, and H are going to be part of your answer. It's not just going to be a number. Why is this important? Okay, it's important because in physics you're going to have a lot of that kind of stuff. For instance, I don't know, give me like a real simple equation that you have in physics. Like VF equals VI plus AT. Isn't that one? You haven't done that yet? And this is February? What is that? Oh, you're doing that? Okay, so what is 1/2 mv squared? Isn't that kinetic energy? All right, we'll do this one. You haven't done this one? You've done acceleration, haven't you? Acceleration is change in velocity over time. All right, well, you've done this then. Because watch, change in velocity is the final minus the initial velocity. I don't know, do you guys use F and I or do you use zeros, naughts? Do you say V naught, that kind of... V0, okay. I always did VIs, because initial and final, I just thought, it's the same exact thing, okay? So watch, over what? T. See, I have this memorized, but what you have to do, I taught physics for a lot of years in my other school, and the way I would get them to remember this is to know the definition of acceleration. Acceleration is the change in velocity with respect to time, okay? Or change in V over T. VF minus VI over T. If I wanted to get VF by itself, okay, now that's what it's going to be, but what math did I do to get VF by itself? Well, what's the first thing you're going to do? Well, you're not going to get rid of what's being added first. What you want to do, this whole thing right here is being divided by the T. So I want to get rid of what that T is doing. The T is being divided by this whole thing. So how do I get rid of something that's being divided? What's that? Why are you whispering? Be bold. Yeah, you multiply. Very good. All right, so you multiply. So multiply this side by T, multiply this side by T right there. So the T's cancel. So what do we have? Let's put it in alphabetical order. Just looks a little prettier, doesn't it? So let's watch. It's AT equals what? VF minus VI. Now what are we trying to solve for again? VF. Okay, one more step and we're done. How do I solve for VF? Add a VI to both sides, right? So here it is. I'll just do it nice and pretty now. If I add a VI to this, I'm going to put the VI out in front. So it's what? VI plus AT, isn't it? Do you see that? Right? If I add a VI to both sides, and so it's VI plus AT. That's how I got that equation. So, Judy, even though you don't remember this equation right here, you said you did remember this stuff right here, right? Okay, well that basically is this equation, isn't it? It's just with VF. Because like in physics, they'll say, okay, the initial velocity is, I don't know, 10 meters per second, and the acceleration is 5 meters per second squared, and the time is, I don't know, 2 seconds. All right? And then what do you have to find? You have to find the final velocity, correct? So you could just plug all the numbers in first and then solve for it, but I tell you what, as things get more complicated, especially in chemistry and physics and things like that where you use a lot of formulas, it's a lot easier, believe me. With numbers like this, you're looking at it and you're saying, you know, I could have just plugged it into here and then solved for VF. It would have been a lot easier just to plug the numbers in first. But you're going to be taught. Does Mr. Jackson teach you that, to solve for the equation first and then plug the numbers in, or any idea?
Usually, we didn't have ones where you had to rearrange first and plug in. It was either to plug in.
So they gave you the formula and you just plug everything in, right? So a lot of times though, when the equations start getting a little tougher, if this is your definition, if that's what you know, instead of plugging the numbers in now and then solving for VF, what they have you do is this. They have you solve for VF first, right? And then everything's real nice. Now I can just plug and chug, right? So let's do this just for fun, see what it is. VI is what? It's 10 plus A, which is 5, and T, which is 2. See how easy it is just to plug that in? So 10 plus 10 is 20, so the final velocity would be what? 20 meters per second. All right, so if you had an object that had an acceleration of 5 meters per second squared, had an initial velocity at 10 meters per second, and it went for 2 seconds, what would the final velocity be? The final velocity would be 20 meters per second. Okay, so are we going to have to do that in here? No, I'm not going to have you plug stuff in like this. There are some problems that they give you that you do that stuff, but I think I kind of left that out just to be nice to you. But you can see where it's useful. Now this is pretty, I mean, some of you guys are looking at this and you're like, oh my gosh, what's he doing? I have no idea what's going on. This is actually very, very basic stuff. There are some equations that get really a lot more difficult, but it's a lot easier to solve for the variable first, okay, with all the algebra stuff, than it is to plug a bunch of stuff in. I'm not going to give you an example where I could show you where it's easier to do that, but I promise it's a lot easier to do that. Alright, let's keep going. Let's do some easier ones. Here's one that you use a lot. Interest equals PRT. We're going to be doing more in another chapter. I don't know, maybe this chapter. I can't remember exactly where it is. I just remember at some point we do a little bit more with this. But all they're doing for here is they're telling you to solve for P. Alright? This is interest, principal, rate, time. And we will be dealing with this a lot more details a little bit later. But right now, all I'm trying to do is get you to solve for P. This is very simple, very much like that volume problem that we just did. Alright, so let's write it again over here. I can do my work over here. So I equals PRT. We're solving for P. That's what we're trying to solve for. Very, very, almost identical to that volume problem. I want to get P by itself, so what do we get rid of? The R and the T. How do we get rid of those? Divide it. Divide by RT here, come over here, divide by RT, and you're done. See how easy that is? That's it. That's your principal. It's the interest divided by, oops, sorry, not equals. What did I do that for? Interest over the rate times the time. That's what the principal is equal to. And that's how you write your answer, just like that. You okay with that? Let's do another one that's just as easy. This is for perimeter. Perimeter is A plus B plus C. Alright? And what you want to do is you want to solve for either A, B, or C. It doesn't make any difference. Alright, let's say we want to solve for, I don't know, B. So here's the problem. Whoops, what's that? Solve for, let's say B. It's pretty easy. I want to get that by itself. So I have to get rid of the A and get rid of the C. Well, how do I get rid of this A? Subtract it. That's right. Subtract an A. How do I get rid of the C? Subtract a C. So what's my answer going to be? P what? Minus A minus C. That's right. Everybody see that? I could have done it over here, right? I could have gone minus A minus C over here if I wanted to. But you see what it's going to be, don't you? And that's all you have to do. There's really no number answer for this, is there? Let's Do another type. Let's do a different color. Let's go this light green. We'll try that. Here's a good one. This is a physics problem. S equals 1/2 gt squared. A lot of times in physics, do you guys use S for distance or D for distance? D. Okay, so there's a lot of books that use S for the distance, or displacement is what they call it. It's kind of weird, isn't it? Use S, you'd think they use D, but a lot of times. G, you used that before. What does G stand for? Right, it's acceleration of gravity. T is for time. All right, but to do these problems in this class, you didn't have to know any of that stuff. All right, it's just free of charge for you. All right, so it won't be in your tuition bill. So what you want to do is you want to solve for G. All right, so that's what we're solving for, G. So I'm going to get G by itself. I'll tell you what, let me rewrite it so I can see what I started with, and then this is what we're going to actually work with. Alright, I want to get G by itself. It's that thing right there. If it helps circling it or underlining it or something like that to remember which one you're solving for, go ahead and do that. So I got to get rid of a couple things. I have to get rid of 1/2 and I have to get rid of t squared. First of all, how am I going to get rid of a 1/2? Subtract? When do we subtract? You only subtract when you're doing the opposite, right? Is there any addition going on here? No, you'd only subtract if something's being added. There's no addition going on here. So this 1/2 is not being added to the G. What's it doing? It's being what? It's being multiplied by the G. So you could divide, right? You could divide by 1/2, but it's a fraction. What do we always do when it's a fraction? We want to get rid of it. Yeah, multiply by the reciprocal. That's right. So how do we get rid of that 1/2 then? Multiply it by a 2. So I come over here and multiply that by a 2. Right? Right? You learned that in Algebra 1, didn't you? I mean, that's basic Algebra 1 principle right there. Okay? Shouldn't be confused on that. So we got rid of the 2. What am I trying to get rid of now? The t squared. Okay, what is that t squared doing to that G? How do I get rid of something that's being multiplied? Divide. So I divide by this. I divide by t squared here. Now, after a while, you don't have to put over t squared. You do that in Algebra 1, maybe early Algebra 2, I don't know. But after a while, you can just see, oh, I got rid of this. But what did I do to get rid of t squared? I divided. So I come over here and I divide this side by t squared. Okay? And that's your answer right there. That's what G is equal to. G is equal to 2s over t squared. There it is. Make sense? Alright, good. Let's do another one. Alright, let's do this one. Scooch this out of the way. Let's try a different color again, just to be fun. What do we got down here? I'm gonna do orange. Let's do this pink one, that's nice. Magenta. Just for Aubrey. Alright, so here we go. S equals, now this S is different. This is not a physics problem. This is more of a geometry problem. 2 pi RH plus 2 pi R squared. Alright, this is S's surface area of a cylinder is what this would be. But again, you don't have to know any of that stuff at all. What we're going to do is we're going to solve for H. I'll tell you what, I'll do it right here. Solve for H. So, where's the H? It's right there. Well, what's going on here? You got something that's being added, don't you? Alright, let's get rid of what's being added first. Alright, before I start getting rid of this 2 pi and r. Okay, you always get rid of, they call it the constant, the thing that's being added or subtracted. I try to get rid of that thing first. So I got to get rid of all this 2 pi r squared. So it's being added, even though there's a bunch of things in here being multiplied times each other, this whole thing right here is being added, isn't it? So how do I get rid of this whole entire thing? I subtract it. So if I subtract it from both sides, I'm going to get S, oops, why do I keep putting equals today? S what? Minus 2 pi r squared. Okay, that got rid of that. See it? Just subtracted it from both sides. Now what am I left with? I'll tell you what, we'll put it right here. 2 pi r h. Again, I'm trying to get h by itself. So what am I trying to get rid of? The 2, the pi, and the r. We've done this a couple times already today. So how do I get rid of the 2, the pi, and the r? Divide, right. Divide both sides by 2 pi r. So if I divide the right side, it's going to go away. Now look, what do I divide over here? Just this part of it? No, the whole thing, right. But the whole thing over 2 pi r. So that canceled, that's h, and that's what we're left with. And that's our answer right there. That's how you leave it. Do the 2 and the 2 cancel out? No, because this is part of a subtraction problem. Remember, we harped on this last chapter, didn't we? Okay, the pi doesn't cancel out with this because this whole thing is part of a subtraction problem. It's not just being multiplied by everything on top. All right, so none of that stuff will cancel out. You just leave it just like that, and that's your answer. What's in the circle right there, that is your answer. You want to do one more? Okay, let me find a good one here. Alright, here's a good one. Change colors. What I want we used. Yellow. I haven't done yellow today. Let's do that one. Alright, here we go. Here's the formula. A equals 1/2 B. That's capital B and that's lowercase b. They're two different variables, even though they're the letter B. Little b and big B. Okay? Everybody with me? And, oh, this is an easy one. Solve for h again. Alright, so we're solving for h. That's what we're trying to get rid of. I'm sorry, we're trying to solve for this. We're trying to get rid of the other stuff. This is actually pretty simple. I must have been thinking of something else. Oh, yeah, it's the one before that. Well, let's do this one, then we'll do the same equation. We'll solve for something else. Okay, so this will be good. So let's solve for h right now. First of all, look, I got 3 things that are being multiplied, right? I got a half times this parentheses right here times this h. So I got 3 things that are being multiplied. I wouldn't do that. It would be a lot easier. You could do, I wouldn't be completely wrong. I'm not saying it would be wrong to distribute the half, but it's going to make things a little more complicated for you, I think. The reason is because since this, and this are all being multiplied, how do you get rid of stuff that's being multiplied? You divide. But this is a half. This is a fraction. Technically, sure, we could divide by a half, but what did we say earlier? Not divide by the reciprocal. Multiply by the reciprocal. There's a big difference. Okay, multiply by the reciprocal. So if I multiply this side by 2, I multiply that side by 2. Everybody see that? So let's see what we have. Let's clean it up. 2a equals big B plus little b times h. Now look, even though this is a plus in between here, it's in parentheses, so it's being multiplied by this h. So how do we get rid of something's being multiplied? We divide. So we divide this side, that'll go away. Come over here, divide this side, and it's big B plus little b. You can put it in parentheses if you want, but there's really no need to because nothing's going on outside of it. Okay? And then you just leave it like that, and you're good to go. Make sense? Alright, let's do the same equation, but let's solve for something else. So what was it? It was A equals 1/2 big B plus little b times h. This time we're going to solve for big B. Solve for capital B. Alright, remember these b's right here are 2 different variables. Even though they're the letter B, you don't write 2b because they represent 2 different numbers, okay? This time, this is what we're solving for. We're solving for this. Now that's a little more complicated than what we did up here because we're solving for something that's inside the parentheses. Alright? See, I was solving for something that was outside the parentheses here, so I could get, you know, I don't have to really mess with this. I didn't have to distribute this 1/2 through this, did I? But on this particular problem, I think, actually, you know what? No, I'm not going to do that at all. What was I thinking? It's almost as easy as this one. Let's do the same thing. This 1/2 is being multiplied by this parentheses is being multiplied by this h. So let's get rid of the 1/2. Again, how do we get rid of the 1/2? We've done it a couple times already. Multiply it by 2, right? And then how do we get rid of the h? Divide it by h. So that'll go away, and we'll get over h. You with me? Let's clean it up. Let's make it look nice and pretty before we do the next step. Everybody see that? I didn't have to put it in parentheses because there's nothing being multiplied by it now because I got rid of all the stuff that was being multiplied by it. Now again, I'm trying to solve for big B, so how do I get rid of that little b? Subtract a b, that's right. So let's so we know it'll go. So we put a minus b, but let's write it nice and pretty. 2a over h minus little b. And that's how we would write our answer. Okay, see that? Alright, so I mean, sometimes there's little tricks to it. But again, you're just trying to get rid of that number. This is actually sometimes a little bit easier than doing like your regular solve for x kind of stuff because you don't have to worry about really any arithmetic, do you? It's just a matter of putting something on the bottom, putting something on top. The only arithmetic we did on these couple problems were multiply both sides by 2, right? That wasn't that big of a deal. So sometimes these are a little easier than working with numbers and things like that. Okay, I think we've done enough to be able to do the rest of these problems. All right, so this worksheet, I think we call it C, and it's got, I don't know, it might be B, I don't know, whatever it is. It's got that Celsius and Fahrenheit problem on there, and it's got this stuff that we just finished doing on here. We good? All right, so I'll give you that worksheet. That'll be due tomorrow. That'll be it.